Hello everyone, welcome to my channel. In the previous video, we solved 12 questions from this exercise. I hope you have practiced those questions well and tried to understand the concept behind each solution. Now, in today's video, we will continue with the remaining questions and solve them step by step. Try to solve each question yourself first, then compare your approach with the solution. So let's begin with the today's exercise questions. Now we have a question number 13 says a fielder in the cricket match throws the ball to the wicketkeeper. At one moment of time, the ball has horizontal velocity 60 meter per second, a velocity in the vertical upward direction of 8.9 meter per second. In question, it is divided into three sections A, B, and C. First section determine for the ball its resultant speed. Now we have given a horizontal speed velocity 60 meter per second and the vertical upward direction as a 8.9 meter per second. Now we have to find the resultant speed. Okay, so horizontal velocity Vx they give us 60 meter per second. The vertical velocity given by Vy 8.9 meter per second. Now first, we have to define the coordinate system, the x direction and the y direction. We draw a vector v of velocity vector of a ball. Now, it made some angle theta with the vx with the x-axis and the length of in the x direction is called vx and in the y direction we have vy. Now, we have to find resultant velocity. So, the given formula of resultant velocity, which is v square is equal to vx square, vy square, 2vy cos theta prime. Here, theta prime is the angle between vx and vy. Here, we have a vy in the direction of y and a vx, which is in the direction of x. Now, the angle between these two is 90-degree because the y-axis and the x-axis they are perpendicular to each other. So we have to put the value of theta here, and we all know the cos theta is 0. Now we get a result like v square is equal to vx square plus vy square. Now put the values which are given to us. Vx is equal to 16 and vy is equal to 8.9. Put this values here and got the result v is equal to 18.3 meter per second. So it is the resultant velocity of the ball. This is the first part. Now the second, they mention the direction, in which direction it is traveling relative to the horizontal. So we have to answer the direction of the ball. Okay. So for this, we can say that from this triangle, we can say tan theta is equals to Vy, means theta is equal to opposite angle Vy upon Vx, corresponding angle. Now we know the Vy and Vx. So put the values 8.9 upon 16 and got the theta like tan inverse 8.9 upon 16 and we got the result 29-degree. So our second answer, which is direction in which the traveling relative to the horizontal, means theta is 29-degree. They mention here the theta is relative to the horizontal direction. If They give they ask like the angle or the direction with the base of the vertical direction. So we have to 90 minus theta means 90 minus 29 degree. Okay, it can be asked like this also. Now in B part, there's a during the flight of the ball to the wicket keeper, the horizontal velocity remains unchanged. That means the horizontal velocity Vx is unchanged. The speed of the ball at the moment when the wicketkeeper catches is 19 meters per second. This is the resultant velocity. Here I mentioned the final speed is 19 meters per second. This is the resultant. Now, what we have to found, which is calculate for the ball just as it is caught, its vertical speed. Now, we have to find a vertical speed. In A section, we find resultant velocity. At this time, in B section, they give a final speed, means resultant speed, or you can say velocity. Here we have to find a vertical velocity. Now, we know the equation is like this, the same coordinate system. So we have a cos theta prime, which is also 90 degree. Same equation used here. So we have a v square is equal to vx square, vy square. And this time we have a v square, but we don't know what vy. This is the vertical speed. So put the values of v square, which is 19 meter per second, and vx, which is 60 meter per second, and try to solve, and you got a 10.2 meter per second. This is your answer. This is the vertical speed. Now, in this, the angle that the path of the ball makes with the horizontal. Again, you have to find the angle with the horizontal. Now, again, do same thing like tan theta vy upon vx. Now, this time put this value 10.2, which we find vy, and vx is already given, which is still same. So, which is 16, and we got the answer 33 degree. Now, in the C section, suggest with a reason whether the ball at the moment it is caught or rising or falling. So, in that we have to say either the ball is falling or racing when it caught by the field keeper. Now, in the C, the ball is falling. Why? I gave a reason here. So, let's try to understand. When the ball was initially at speed, which is given 8.9 meter per second, while vertical speed, okay, and a moving upward, okay, if batsman hits the ball like this way, okay, the vertical speed is 8.9. Why? Moving upward as a projectile means a ball travels through the air, okay, gravity, and deaccelerates its upward motion. Okay, we know the gravity always pulls towards Earth, okay, means G, and which is also constant, which is direction of downward, and peak hits a peak and then it accelerates downward. Let's suppose the ball is here and it is hit by the batsman and it will its motion is like this. Okay. Now here it is a peak position. After reaching the peak position, the ball moves downward. Why? Because of G is acting upon it. It's only a downward. That means they give in a B, okay? The horizontal velocity remains unstable because there is no horizontal force. Force is only on downward direction, okay, on a vertical, which means the effect of G only on vertical speed, not a horizontal speed. So as E reach the peak position, the ball is moved in downward direction, and because of G is acting upon it, it will move faster, and means it is a accelerating speed. So that means accelerates in downward direction. Since the final vertical speed when caught by the keeper is 10.2 meters per second and initial is 8.9. Try to understand this is a projection of ball. It is sometime here, sometime here. So when the initial speed is 8.9 and it decreases when it goes to the peak position. So that means the speed when by the chord is 10.2. That means after reaching up its peak, it will gain some speed and accelerated by g. So greater than the initial speed. This is the greater than initial speed. Means the initial upward vertical speed, this ball must be have already passed its maximum height, which is this peak, and gained speed while moving downward the gravity. So when ball is falling, okay, and fielder is here and catch by the fielder, okay, means ball is falling. Why? Because its initial speed means 8.9 meter per second, which is when it goes to peak position, it comes down to zero. At the peak position, its speed is zero, and whenever it goes down, because of the gravity, it accelerating, accelerate the ball, and it catch by this speed. Okay, so that means ball is falling. I hope you understand the concept well. Now, this is all about question number 13. Now, we move on question number 14. It is divided into uh, six, five question, five sections. For A, the spacing between two atoms in a crystal is 3.8 into 10 raised to minus 10 meter. State this distance in pm. Pm means we have already saw the meaning of pm and what is the value and what is related to meter. Okay, now here we have this value 3.8 into 10 raised to minus 10 meter means we already seen that 1 meter is equal to 10 raised to minus 12 picometer. Now we have a 3.8 into 10 raised to minus 10 meter. So we have to just add, multiply by minus 2 and into 10 raised to plus 2. We have a 10 and 10. Base is same, so we all know this will be 10 raised to minus 12. And multiply 10 raised to 2 into 3.8 and you got the result 380. So answer is 380. Okay, and this is pm. Okay. That means our answer is 380 pm. Okay, if you write 380 into 10 raised to minus 12, which is in meter. Okay, Now, in the B part, they ask calculate time of 1 day in mega second. Okay, we also seen in the order means 1 megasecond is equal to 10 to 6 second. Okay, I hope you remember it. In the B section, 1 day, if you want to convert into hours, you have to multiply by 24. And again, we have to calculate in seconds. So we have to multiply by 60 into 60, 64 minutes and 64 seconds. So if you multiply this quantity, then you will get 86400 second. Now, we need in megasecond. We all know 1 megasecond is equals to 10 to the power 6 second. And we have this amount of second. So write like this. You multiply by 6 or and now multiply by these two factors. Okay, if you multiply 10 to the minus 6 with this quantity, you will left with 0.864 into 10 to the power 5, 6 second. You have to convert in megasecond. Okay, so you have to eliminate this and we'll get this quantity 0.0864 millisecond. Now, in C part, the distance from the Earth to the Sun is zero point 0.5 terameter. I hope you know the what do you mean by a terameter means 10 to power 12 meter. Okay. Now calculate the time in minutes, not a second here, for a light to travel with from the sun to the earth. We have to calculate the time in minutes, okay, for a light to travel from earth to sun. For this, we need the distance between these two, which is 0.15 terameter means into 10 raised to 12 meter. So already convert in SI base unit. Okay. Now we all know that the speed of light in the space, which is 3 into 10 raised to 8 meter per second, uh, apply some simple formula, which is a speed. Speed is equals to distance upon taken time. So here we have to find the time. Okay. So make it subject and we have a formula like distance upon speed means this upon this. So we got the answer 500 second, but they want answer in minutes. So you have to divide by 60. Now you will get answer in minutes and it is 8.3 minutes. Okay. In question D, identify all the vector quantities in the list below. Now they give a 5 different physical quantities. From this, we have to find vector quantities. Okay. If there is a no vector quantity, means they are scalar quantity. Let's go step by step. First one is distance. I mentioned in my previous video the distance is uh, scalar quantity. Energy. Energy has a unit, joule. Okay. And which is also a scalar. Now, momentum. Momentum is given by m into v. Here, m is mass, which is a scalar quantity. But here, V means not a speed, it means velocity. You all know velocity is a vector quantity. From that, we can say P is a vector quantity, means momentum is a vector quantity. Okay, we have got this. And weight. In my first or second video, I mentioned the weight is also a vector quantity, which is W is equals to mg, and its unit is in Newton. Okay. Now work has also unit is a joule, and it is not a vector quantity, means it is a scalar quantity. Now our answer is momentum and weight. Now in each section, they've asked the velocity vector diagram for aircraft heading due to north is shown to scale in figure 1.36. There is a wind blowing from northwest. The speed of the wind, which is 36 meter per second, and the speed of aircraft, which is 250 meter per second. They give information all about the figure and the speed of them. Now, in the first part, they ask make a copy of figure 1.36, which is already shown here, and draw an arrow to show the direction of the resultant velocity. Okay. You know, velocity is a vector quantity, so it is not like a add something like a scalar. So we have to add tip to tail method of the aircraft. Okay. First, we have to draw. Now, they say aircraft is heading towards north. Let me define the direction north, south, west, and east. They give aircraft if aircraft is heading towards north, and the wind in the direction of north northwest. Let me see, northwest, which is already shown here, and it make an angle of 45 degree here. Now the vector, the direction of this arrow is very important for when you deal with vectors. Means this is the wind speed and this is the aircraft. Now we know what is the tip to tail method. First, draw a aircraft vector. Now this is the name of VA. Now the wind is actually like, or it is about like this. This is the VW. Okay. Now we have to find the resultant vector. We have to draw. Means draw a resultant vector like tail here and top of the match with the VW. This is the VR. And do not forget the arrow on every vector quantities. Okay, this is the identification of the vector quantities. This is drawing. Okay, we drew a resultant velocity vector. Now, second one, which is determine the magnitude of the resultant velocity of the aircraft. So we have to find the resultant velocity. Okay, it's all about the drawing. Now we have to find a magnitude. What is VR? Okay, so for that we have a formula like resultant vector VA square VW square plus I here plus, and it is about um, cos the angle between these two vector. and they give a given is a VF cut speed is given, and the 45-degree southeast. Okay, southeast is this, and this is north. This is the one first vector, and this is the second vector. Now we have to find what is the angle between them. So the angle which is they given a 45-degree angle. Okay, and the 90-degree angle is here. We all know. So you have to adjust that. 90 plus 45 means 135. If you put this value here, means cos 30, 135 value. All this is in degree. In order to convert in a radian part, means pi by 2 plus pi by 4. According to trigonometry rule, the pi by 2 means change the function. Here I mention in which section which functions are positive or negative. It gives us pi by 2. Pi by 2 means 90-degree plus something. Something means 45-degree. Means this talk about second quadrant. In second quadrant, sine is a positive, and all other are because pi by 2 here. If now, what is the value of sine 45? Means 1 upon root 2. Okay. Put the values of here. We also know VA, VW, VW means V wind, and VA means V aircraft. Now, uh, we got the resultant velocity 226 meter per second. Okay. Now, I also forget about arrow. Now, this is all about the answer of E. First, we make resultant vector, and then we find the value of resultant vector. It's all about question number 14 and 13. Now we go on question number 15. In question number 15, there is also a two part. Okay. In A part, state the SI base units of volume. Okay. Uh, we know volume. Volume means length cube. We also mention here volume is a length cube and means meter cube. Length has a SI unit of meter and cube and meter cube. Now, in second, show that the SI base unit of pressure are kilogram per meter second square. So you have to show the unit of pressure. For that, you have to first, the what do you mean by pressure? Pressure is the force per unit area, and the formula is force upon area. We already know what is the SI unit of force, which is a Newton, and Newton is given by kilogram meter per second square, which is base SI units. Okay, and for area has a meter square. If you divide, you got kilogram meter to second square. Okay, from that you got the same units, and you show the same result. Okay, now in B section, they ask us the volume V of the liquid that flows through the pipe in the time t given by a equation. There is a pipe, and the volume V of the liquid flows through the pipe at time t, okay, and given by this formula. They already give a formula and they mention about each quantity, which is where P is the pressure, okay, pressure difference between the two ends of the pipe, radius R, and length L, okay. The constant C depends on the frictional effect of the liquid, okay. So determine the base unit, okay. We have to find the unit of C, okay. We already know what is the unit of V, T, P, R, L, okay. So they give a formula, make sure the do subject what we have to find. You have to find C's unit, and here to find a unit, pi is the absolute quantity, AT has a no SI unit, so P means P has a phosphor unit area, and we also derived it kilogram meter into second square. R means radius, kilometers raised to 4. T means time, means second has unit. V means meter cube, and L means meter. So cancel it, and you got kilogram here, and the denominator you will get meter into second. Okay, this is the match this answer. Okay, and you can say the unit of C, which is kilogram per meter into second. This is all about question number 15. Now we going towards 16. In A, make estimates of the mass in kilogram of wooden meter rule. You can do as well at your home. Make take some wooden meter rule and do some weight. The typical wooden meter rule has a mass around zero point 0.1 kilogram. And the second part, they say we have to find volume in centimeter cube, the cricket ball, or you can say tennis ball. If, in order to find the volume of the cricket ball, you have to know about what is the radius of cricket ball. Here I take 3.5 centimeter as its radius. I put this value in volume formula and I got the 200 centimeter cube volume. Okay, you can do as well at your home. Now, in the B part, they show a cylinder, you get a metal wire, which is also similar kind of cylinder, as a length L, has a circular cross area section of diameter D, as shown in figure. What is volume of the wire is given by the expression. Okay, we also know the volume of the cylinder is pi s square L. Okay, they write here. The distance D, length L, mass M are measured to determine the density of metal. Okay, metal wire. The measured values, they give some values of diameter, length, and mass. Calculate the density of metal with its absolute uncertainty. So we have to find not just only a density of metal wire, but we have to add or we have to find uncertainty due to some measured value. Okay, here you can see some is the delta D here, delta L here, and delta M here. That's why we have some delta rho is there. Give your answer an appropriate number of significant figures. Okay, so in this you have to find a density. You know the formula of density, which is mass per volume. Okay, we know the mass, but we don't know the volume. They give us formula may like d square upon 4 into L, and they give a value of d and L as well. So first we have to find the volume by using exact values. This this value. Okay. Now try to put here values and you got the answer 0.0283 centimeter cube. Okay. But we have to find rho, means density. And they give a mass upon volume. If you do this upon this value, and you will get 10.95 gram per centimeter, which is not SI base unit. So we have to convert first in SI base unit. How to do it? This is numerical value, okay? Gram. If you want to convert gram into kilogram, multiply by 10 raised to minus 3. Centimeter cube here, 1 centimeter into 10 raised to minus 2 meter. But here, centimeter cube is in denominator. So, in denominator, we have to multiply by with 10 raised to minus 6 because we have cube here, not single. So, next, simplify, and we got into SI base unit, which is 7.95 into 10 raised to 3 kilogram per meter cube. This is density. We got this density by using exact values. For we have to calculate uncertainty as well. For uncertainty, we have a formula. Here I consider only d square L. In volume formula, we have a pi d square by 4 into L. But here we have to find uncertainty. Here pi is the exact value. Okay, so you have to eliminate it. 4 is exact. There's no uncertainty in that. So you have to eliminate and you left with d square L. That's why I write here d square L only. So in my first video, I mentioned how to find uncertainty. Okay, so formula is like this: delta rho upon rho, and in upward there's a delta m upon m plus 2 delta d upon d and delta l upon l. Why do multiply by 2 with this quantity only? The answer is here in we study there is some power we study, and it in my beginning of my lesson plan I write like this kind of formula. If you want to find delta x, so the formula is given by like this delta y upon y. This is the formula of uncertainty. So this is multiply by 2 because there is a square. If there is a cube or you can say a third power, so you have to multiply by 3. As well, here I multiply by 1, but I didn't show because that means it doesn't affect, okay? So mention, make a note and of power multiply by 2. Here power is 1, so we have to multiply by 1. And here is also power 1 and multiply by 1. By this way, you can easily remember the formula, okay? And you got to put the values here. Delta M means this value. Delta L means this value and delta D means this value. And you also know the what is the value of D and L, LM, and put this value and you got the 6.1. And to find delta D, and we know the rho, so multiply by these two values and you got the value 485 kilogram per meter cube. This is the uncertainty. Okay. Now the final answer is rho exact value plus some kind of uncertainty means this one into 10 raised to 3. Uh, you know, you do not confuse with this value. If I write like this, okay, don't confuse and get common 10 raised to 3 by this two term, okay. And at last, they gives some last line which is Answer to appropriate number of significant figures. So this is not a significant numbers. So you have to just this is almost like 8. Okay, to write 8 plus or minus, and this is like 5, which is very near to the 5. This is 5 into 10 to the power 3 kilogram per meter cube. This is a significant answer, we can say. Okay, this is all about the question number 16b. Okay, and now we go on question number 17. In question number 17, there is a two part. Okay, A, the defined pressure. In a last question, we also defined it. So the definition is like pressure is the force acting per unit area. Let me give us some. This is the kind of surface. Okay, if you exert some force on that area, let me give you this cross section area is A, and if you want to find the what is the pressure on this area, so you have to just force per unit area means whether it is a square, whether it is a rectangle, whether it is a circle, you just put it here as area of that shape. Okay. Now the which is given by this kind of formula. Now in the second question, show that the SI units is pressure is kilogram meter square meter per second square. We already seen question number 15b, the same thing. Okay, I'm not repeating it. Okay, so now we go on part B. They ask gas flows through the narrow end nozzle of the pipe under the certain conditions. The mass m of the gas that flows through the nozzle and the short time t is given by. This is a formula they give us where k is a constant with no units. So try to remember while solving this question, k is a no unit. Where c is a quantity of depends on the nozzle size, but they didn't mention about the unit of c. Now rho we know density given by kilogram per meter cube, mass per unit volume around the nozzle, and p is the pressure. Okay, so we have to find the base unit of c. Okay, so in this question we have to find base unit of c by using this equation. So let's this is the formula. So we have to find the unit of c. So make a subject of this question, and we got formula like this. This is a mass. Mass means kilogram. S square, do square. In denominator, we have a t square means second square. K square means here I mentioned k has a no units. So to find units of c, eliminate. Now we have rho. Rho means mass per volume means kilogram per meter cube. And the last pressure means Newton per meter square. Okay, means here kilogram meter second square. So do some kilogram is cancel it out here, and second square is also cancel it out. There's meter cube into meter, it means meter to 4, but it is the unit of c square. But in the question they ask about c, so c unit as a meter square. So be careful while reading the question and while doing some examples and solutions. So some students left with this m raised to 4, but they get wrong answer. The right answer is meter square. This is the 17 question. Now go on 18 question. Again, this is a divided into two sections, A and B. So in A, the analog voltmeter. The voltmeter is used to find or measure the voltage difference between any two points in the circuit. It may be a resistance, it may be some kind of load. Okay, it is to take a measurement, a constant potential difference. Okay, across the resistor. That means if you have some resistor here, if you find what is the voltage difference, okay, or potential difference between these two points, you have to just add parallel to this circuit. Okay, keep in mind, voltmeter is always joined with the parallel, not in series. Unlike the ampere meter, which is used to measure the current, okay, it is also in always in series and it is always in parallel. So hope you mind it in your head and try to recall it and remember when you do some experiments. Now, for these measurements, describe one of the example of, okay, we have two errors, systematic and random error. In my first lecture, I mentioned about these two error in detail. So I'm not going to in detail at this time, but here I take some scale, okay? Uh, Consider it is a voltmeter scale. Now, first we go systematic error. So what does it mean? Systematic error means calibration error. Consider some scenario like if we have a voltmeter in our lab. Now, if a voltmeter is not using, means there's a no potential difference between the voltmeter, but still the pointer shows one. Okay, that means the problem is in voltmeter. Okay, whenever you perform some experiment with this voltmeter, and let me suppose you find a potential difference between resistor, and you will find and you will get like 3 volt, 3 volt potential difference. Okay, but in actually there is a 2 volt. Why? Because it's already show a needle show up in it one. Okay, when there is a no in use, there is a no use of voltmeter. It shows two, but whenever you perform and you will get the result like 4 volt, you have to just subtract 2 volt from that and you will get the right result. Okay, so this is the one thing I have to mention. And another thing, while you perform the some kind of experiment, first you have to see that there is any discrepancy or there is a needle where is the needle. If needle is at zero, it that means the voltmeter is very they give perfect result. But if there is some kind of discrepancy like at one or at some kind of somewhere else here, so you have to just note it down, and then after doing some experiment, you have to just subtract it from the what you get in result. Okay, that's how you eliminate this kind of error. Now, in the second one, which is a random error, which is not like a instrument error, it is because of the some kind of environment issue, or you can say it may be some person to person. Okay, means uh, while you're doing some experiment, the pointer shows like this. A student says it is like 1.3. At the same time, student B says, no, it's 1.2, but it shows a perfect. But there's a difference between these two students. Take some different readings and they will get some different results. Okay, so make sure when you get reading takes 2 times and or 3 times and do average what you get. Okay, if you get one 1 volt, 2 volt, and 3 volt, so you have to just do some average. Okay, like this, and you will get near to the accurate one. And sometimes there will be a fluctuation in the circuit. Okay, when there is a no some kind of there is a leakage current or some kind of not properly work any kind of instrument, there is a fluctuation. Okay, it is also a reason for the random error. And this is all about systematic and random error. So in 18A question, it is all about theoretical knowledge. In B, they give us a potential difference across the resistor is the 5 volt plus or minus 0.1 volt, and this is the value of voltage. Okay. Now the resistor is labeled as having the resistance, and they give us a resistor value. Now we have to calculate the power dissipated by the resistor. And in second, calculate the percentage uncertainty. Okay. We also have to find uncertainty. Okay. I also, okay, this gave us in resistor uncertainty and voltage uncertainty. And the calculate power. Determine the value of the power with its absolute uncertainty to an appropriate number in significant figures. Okay. Here they also mention some significant figures. Okay. Now you have to first find power, absolute value of power. So we have a V, 5, and 125. And remember the value formula of power, which is V square upon R. There's a other formula like I square into R. And IV is also a formula of power. Okay. Here we have a value of V and R. So we use this kind of formula. But if we have a value of resistance and current, then we use this formula. Or if we have a voltage and current, we use this formula. Okay, put V square 25 upon divided by 125 and you got the result 0.2 volt. Okay, this is the absolute result. Now we have to find percentage uncertainty. By this formula, we already seen how to write delta P upon P is equals to 2 because here power is 2. So delta V upon V plus delta R upon R. Now delta V means zero point 0.1. Delta R means here one thing is they give us percentage. Okay, so you have to just write instead of this only 3% because they give already a in percentage. So we don't find in percentage value. In delta V, we don't have a percentage value. So just do 2 into zero point 0.1 upon 5 into 100 plus 3 and it will result in 4%. So 4 plus 3 means 7%. And delta P value P into 7 means 0.014 volt. Okay. Now write P is equals to zero point 0.2 plus or minus 0.014 volt. Okay. Right kind of solution. But here they give a significant figure. So this is also a significant number. But here this is the less than 5, so we can eliminate by just not adding 1. If there is a 6 here, So you have to do 0.02, but it here it is not 5 or more than 5, so you have to just eliminate and you will get 0.01 volt. This is the final answer. And this is the answer of B. Okay. This is all about question number 17 and question number 18. I hope you understand these questions and approach. Some questions still remain, and we will discuss those questions in my next video. Thank you for watching. Subscribe for more physics lecture.